Hello everyone, and today I'm starting the very important topic from the class 12th chapter, that is solution, and the topic name is vapor pressure, right? So in the beginning of this lecture we are going to understand the basic meaning of vapor pressure and what are the various factors that affects the vapor pressure. So let's begin with the definition of the vapor pressure, right? So the heading is vapor pressure. Heading is vapor pressure. Okay, now what is the meaning of vapor pressure, right? So in order to understand, let's understand this first. Suppose we have water in this container, okay, and we closed it. It's a closed container, right? Okay, so this is our water. Okay, and this is what kind of container is this? This is closed container. This is closed container. Okay, now at certain temperature, what will happen? Suppose if we are doing this activity at 25 degrees Celsius, so at certain temperature, what will happen? Evaporation will start. Right? Evaporation is a spontaneous phenomena. Evaporation will start, and during evaporation, what will happen? That liquid will convert itself into vapors, right? So these are vapors. Liquid will convert itself into vapors. So these are vapors. Clear? Okay. So there are two kinds of phases there. I can call this phase where vapors are present. I can call this phase vapor phase. Okay. This is our vapor phase, and we will call this phase where water is present. This is our liquid phase. This is our liquid phase. Clear? Okay. Now the most important point is that evaporation is going on at certain temperature, and due to the evaporations, liquids are converting themselves into vapors, right? Now you guys know very well that evaporation is going on, and evaporation is surface phenomena. Evaporation is what? Evaporation is surface phenomena. So in surface phenomena, only surface particles are involved. Only surface particles are involved. Clear? Only surface particles are involved. So right now we are performing this activity at a certain temperature. So temperature is constant. T is constant. Well, let's say it's 25 degrees Celsius, and the surface area of this beaker is also constant. Right? We are not changing any other factors. So if we are not changing any other factors, so I can say that the rate of evaporation, okay, evaporation is going on, but the rate of evaporation since temperature and surface area is constant. Surface area is same. Since temperature and surface area is same, rate of evaporation since temperature and surface area is same is constant. Okay, because you guys know very well, if you will increase the temperature, then rate of evaporation will increase, and if you will increase the surface area, then rate of evaporation will increase. But for this activity, the temperature and surface area is constant. The temperature and surface area is constant. Clear? So if I draw a graph over here, this is rate, okay, this is rate versus time. This is, guys, what? Rate versus time, right? So if I draw a graph for rate of evaporation, so at a particular time, for this particular time, since temperature and area is constant, rate of evaporation is to constant. So this is the graph for linear graph, okay, straight line. Graph is for rate of evaporation. This is the graph for rate of evaporation. Point is clear? Why I am drawing the straight line graph? Because at this particular moment, temperature is constant and area is constant. That's why rate of evaporation graph will look like this. Okay, now what is going to happen? Rate of evaporation is still constant. So at a certain time, so much vapors will be collected in a vapor phase. Right? Then after that, what will happen? After collecting of so many vapors, what will happen? that these vapors will try to convert themselves into liquids. These vapors try to convert themselves into liquid. What happens when you boil something and if you put a plate over the pot where you are doing the boiling, what will happen? That the vapors will condense themselves. They will convert themselves into liquid. So same kind of thing will happen here. First the evaporation will start and the evaporation will be constant. So after certain time, vapors will collected over in the vapor phase, okay, and after certain time, what will happen with those vapors? They will start to condense themselves into vapors, and condensing of vapors is known as what? Condensing of vapor is known as what? Condensation. Condensing of vapor is known as what? Condensation. Okay, so at certain time condensation will start. At certain time condensation will start, and let me tell you, rate of evaporation is to constant. Rate of evaporation is to constant, right? But at t equal to 0, rate of condensation was 0. As time is increasing, rate of condensation is also increasing. Okay, so for rate of condensation, the graph that we are going to draw, is this. Okay, so this is the graph of as time is increasing, rate of condensation is also increasing. So this is the graph for guys, this is the graph for rate of condensation. This is the graph for rate of condensation. Okay. So rate of evaporation is to constant, but as time is increasing, rate of condensation is increasing. Point is clear? Okay. Now at this point, you can see at this point what is happening, that the rate of condensation and rate of evaporation becomes equal. At this particular point, rate of condensation and rate of evaporation becomes equal. What does it mean? It means if I consider the conversion of liquid into vapors forward reaction and the conversion of vapors into liquid backward reaction, so what is happening at this point? At this point, rate of forward reaction is equal to rate of backward reaction, right? And this is the condition of in a reaction when rate of forward reaction is equal to the rate of backward reaction. This is the condition of dynamic equilibrium. Yes or no, right? So at this point, the point where rate of evaporation and rate of condensation will become equal, this is the point of dynamic. This is the point of dynamic equilibrium. This is the point of dynamic equilibrium, right? Why I am calling this point dynamic equilibrium? Because at this point, rate of evaporation and rate of condensation becomes equal. Clear? Now, at this dynamic equilibrium point, okay, there will be some vapors that will be left in vapor phase. It's not like that the whole vapors are converting themselves into liquid. No, there will be a point. At that point, rate of evaporation and rate of condensation will becomes equal. And at that point, there will be some vapors that will be left in the vapor phase. Okay. So now the left vapors, what the left vapors will do? They will come on the liquid surface and they will exert a pressure. Okay, the left vapors, after fulfilling these conditions, comes on the liquid surface and exert pressure, and that pressure is called vapor pressure. That pressure is called what? Vapor pressure, right? So if I want to define vapor pressure properly, so how I will define it? So I will define it, the pressure exerted by the vapors on the surface of the liquid, the pressure exerted by the vapors on the surface of the liquid when liquid phase and vapor phase are in dynamic equilibrium. That pressure is called guys what? That pressure is called vapor pressure. I hope the point is clear to you regarding the vapor pressure. Okay, so like if I ask student define vapor pressure, so what they usually tell, they tell the pressure exerted by the vapors on the surface of liquid is called vapor pressure. So this is the wrong definition. Because why? Because you have to mention the equilibrium condition. When equilibrium will set up, then whatever the vapors that are left in vapor phase, the pressure exerted by those vapors on the surface of liquid is vapor pressure, right? So whenever you are defining vapor pressure, you have to mention this condition specifically, that the rate of evaporation is equal to rate of condensation. Clear? That is what is the why we are taking this container close, because we want equilibrium to establish, right? If this container would not be closed, what will happen? what will happen, that vapors will escape, and if vapors will escape, there will be no equilibrium, and if there will be no equilibrium, there will be no concept of vapor pressure. There will be no concept of vapor pressure. Okay, so I hope the point is clear to you. So now I'm writing the definition of vapor pressure here. Okay, so the definition of vapor pressure is the pressure exerted by the vapors, pressure exerted by the vapors on the surface of liquid, pressure exerted by the vapors on the surface of liquid when liquid phase and vapor phase are in dynamic equilibrium. When liquid phase and vapor phase are in dynamic equilibrium. Okay, so this is the most important definition of pressure, vapor pressure. The pressure exerted by the vapors on the surface of liquid when liquid phase and vapor phase are in dynamic equilibrium is called vapor pressure. Is called what, guys? Is called vapor pressure. Okay, so this is the definition of vapor pressure. I hope the definition is crystal clear to you now. The definition of vapor pressure is crystal clear to you now. What are the key points? For vapor pressure? First key point is we can only define vapor pressure when liquid phase and vapor phase are in dynamic equilibrium. And second point, what is the meaning of dynamic equilibrium? The meaning of dynamic equilibrium is that the rate of evaporation and the rate of condensation is equal, right? And the third and last important point is this, the graph, right? Like in competitive exam, not for CBSE, but in competitive exam, they can ask you which of the following is the correct representation of graph related to the vapor pressure. So okay, so please keep in your mind that since temperature and area of the container is constant, that's why the rate of evaporation is constant. What is increasing? Rate of condensation, and the point where rate of evaporation and rate of condensation will meet, that is the point of equilibrium. And whatever the vapors left in that point in vapor phase, the pressure exerted by those vapors on the liquid surface is called what, guys? Is called vapor pressure. Right? So this is the important part, this is the important definition of vapor pressure. Now after the definition of vapor pressure, I hope the definition part is clear to us. After the definition of vapor pressure, now I will start what are the various factors that affects vapor pressure. Okay, so let's start with that also, various factors that affects vapor pressure. So I'm writing the heading now. Okay, after the definition, guys, we have factors affecting vapor pressure. After this, we have another point, that is factors affecting vapor pressure. Okay, so what are the various factors that affects vapor pressure? Okay, factors affecting vapor pressure. Okay, so let's start with the various factors that affects the vapor pressure. Okay, so the first factor is, guys, nature of liquid. First factor is nature of liquid. Okay, so I will tell you about the nature of liquid. Okay, so in order to explain this, I will explain it with the help of one question. Okay, so suppose we have water. Okay, we have alcohol and we have ether. Okay, this is water this is alcohol, okay, and this is ether. Water, alcohol and ether. Okay, this is the general formula of ether. What is the general formula of ether? ROR. ROR. ROH is alcohol and water. Now we want to compare their vapors. We want to compare their vapor pressure. Okay, we want to compare their vapor pressure. So now pay attention over here. Tell me, in case of water, these two hydrogen can form hydrogen bond. Yes or no? These two hydrogen can form what? Hydrogen bond. Okay, and here, how many hydrogen can form hydrogen bond? Only one hydrogen can form hydrogen bond. Okay, which kind of hydrogen can form hydrogen bond? Those hydrogen which attach to phone, that is fluorine, oxygen and nitrogen. So here hydrogen is attached to oxygen, two hydrogens are attached to oxygen, so they can form a hydrogen bond. Here only single hydrogen is attached to oxygen, so only one hydrogen can form a hydrogen bond. What about ether? In ether, hydrogen bonding is not possible. No H bonding. No hydrogen bonding. Okay, no hydrogen bonding, no H bonding. Okay, weak H bonding, weak hydrogen bonding, I can say that. Okay, and here what about what kind of H bonding? Strong hydrogen bonding. What kind of hydrogen bonding here? Here hydrogen bonding is strong. Clear? Now what is the meaning? This strong hydrogen bonding means if you want to convert water into vapors, so it will require more energy. It will require more energy to convert water into vapors because water molecules are strongly attracted to each other with the help of strong hydrogen bonding. Okay. Now what about ether? In case of ether, since intramolecular forces are weakest, if intramolecular forces are weakest in liquid particles, what does it mean? With less amount of energy or with less temperature, you can convert themselves into what? You can convert themselves into vapors. Right? Yes or no? Right? So that is why if I ask which one will have maximum vapor pressure, so the one that can easily convert itself into vapors will have more vapor pressure. And which one can easily convert itself into vapors? Ether can easily convert itself into vapors. Why? Because ether has weakest intermolecular forces, right? So from this discussion, I hope now I can write for you that vapor pressure is inversely proportional to intermolecular forces. Can I write that? Okay, that vapor pressure is inversely proportional to intermolecular forces. If the intermolecular forces are strongest, then what about the vapor pressure? Vapor pressure will be least. And if the intermolecular forces are least, what about the vapor pressure? Vapor pressure will be maximum. Clear? So where the intermolecular forces are least, it is in case of ether, because in case of ether there is no hydrogen bonding. So if I want to compare the order of vapor pressure, then this will be the order of vapor pressure. Okay, so I hope now you can relate vapor pressure to the intermolecular forces. That's why ether will have maximum vapor pressure. If you will put ether on your palm, instantaneously it will convert itself into vapors because it is very much volatile. Volatile means what? Volatile are those substances which has more vapor pressure. So ether is the most volatile, right? So I can also say that, okay, since its vapor pressure is maximum volatile. I can say that it is max volatile, right? Okay, now what about the second question? Second question is also on discussing on the basis of nature of liquid also. So the question number 2 is, now you have to tell me the answer. Question number 2 is again increasing order of vapor pressure. Again increasing order of vapor pressure, right? So we have ethanol, CH3CH2OH, this is known as ethanol, and we have CH2OH, CH2OH. Okay, this is what? This is ethylene glycol, ethanol. Okay, this is ethanol, this is ethylene glycol, and last one is CH2OH, okay, CH2OH. Okay, so this is what? This is glycerine. Okay, this is glycerine. So we have ethanol, we have ethylene glycol, and we have glycerine, and we have to arrange them in, let's say, in decreasing order of vapor pressure, right? So now again, vapor pressure is inversely proportional to what? Vapor pressure is inversely proportional to intermolecular forces, right? So here, how many hydrogen can undergo hydrogen bonding? One hydrogen. Here, how many hydrogen can undergo hydrogen bonding? Two hydrogen. And here, how many hydrogen can undergo hydrogen bonding? Three hydrogen, right? So where intermolecular forces are the strongest, okay? So strongest intermolecular forces are strongest because three hydrogen can participate into hydrogen bonding, and here in case of ethanol it is weakest. In case of ethanol it is weakest. So if I ask you the correct order, of vapor pressure, then what will be the correct order of vapor pressure? Since here it is weakest, so vapor pressure will be maximum. So first for this and this. So this is the correct order of vapor pressure. Ethanol will have maximum vapor pressure, and glycerine will have least vapor pressure. Yes or no? Clear, guys? Okay, so I hope this concept is clear to you, that vapor pressure is inversely proportional to intermolecular forces. Okay, now I can explain one more concept with the help of this only, that this is the order of vapor pressure, decreasing order of vapor pressure. If I will ask you whose boiling point will be maximum, right? So what do we understand by boiling point? So there are two ways that I can connect this to the vapor pressure, but first of all I am connecting with this definition only, right? So what is the meaning of boiling point? What is the meaning of boiling? Conversion of liquid into vapors, right? Which kind of liquid will take more time, more temperature? Which kind of liquid will take more temperature to convert itself into vapors? The liquid where intermolecular forces are strongest. If the liquid having strongest intermolecular forces will take maximum time to convert itself into vapors, right? So here, can I say that vapor pressure is inversely proportional to intermolecular forces and inversely proportional to boiling point? Why? Because if I write like this, it means boiling point is directly proportional to intermolecular forces. More intermolecular forces, more boiling point, and less vapor pressure. Okay, so please keep in your mind that vapor pressure and boiling point are inversely related. Vapor pressure and boiling points are inversely related, and the reason, I hope the reason is also clear to us. So suppose if I ask you compare the boiling point, so whatever the order of vapor pressure, you have to just reverse it. Here also, if I ask you to compare the boiling point, so whatever the order of vapor pressure, you have to reverse it. That's it. Yes or no? Point is clear to everyone? Okay, so this is our first factor on which vapor pressure depends, that is nature of liquid, right? So in JEE Main 2020 attempt, in January attempt, they asked one question based on this concept also. So we will see that question later after discussing the whole factors, like the list of all the factors. Then I will discuss that questions with you as well, right? So I hope the first point is clear to us, nature of liquid. Now, what is the second factor? So what is the second factor now, guys? Second factor is very, very important to us. The second factor is temperature. Second factor is temperature. Okay. So what will happen to the vapor pressure if you will? What will happen to the vapor pressure if you will increase the? What will happen to the vapor pressure if you will increase the temperature? This is the question. Clear? So guys, how can I explain to you that what is vapor pressure? Vapor pressure is the pressure when liquid, H2O liquid and H2O gas, liquid phase and vapor phase are in equilibrium. Okay, that time what is the pressure? That is vapor pressure. If I want to write the Kp expression, equilibrium constant expression, what I will write? We don't write in the expression of Kp or Kc, we don't write pure liquid and pure solid. So I will only write for gases we use partial pressure. So partial pressure of H2O, and this partial pressure of H2O is also what? This partial pressure of H2O is also what, guys? This is also vapor pressure. Okay? Okay, now tell me, what kind of process is this, liquid to gas? It is exothermic or endothermic? This is endothermic. This is endothermic. And we have learned this in class 11th, that if the process is endothermic, then on increasing its temperature, if it is endothermic, then on increasing its temperature, value of equilibrium constant also increase. We discussed it in 11th standard equilibrium chapter. And if it is exo, then if you increase the temperature, Kp, Kc will decrease. But if it is endo, if you increase the temperature, Kp value will also increase. So if you are increasing the temperature, Kp value is also increasing. If Kp is also increasing, it means partial pressure of water is also increasing. And partial pressure of water means vapor pressure is also increasing. This implies PH2O. This implies PH2O is also increasing. This implies vapor pressure is increasing. Vapor pressure is increasing. Okay. So on increasing temperature, I can say that the value of vapor pressure will increase. So if you increase temperature, vapor pressure will increase. Clear? Now, the next is like what kind of relation, like if I want to draw a graph in JEE in 2013 or 2014, they ask one question based on the graph. This is vapor pressure and this is temperature. So if I want to draw the graph between vapor pressure versus temperature, what this graph will look like? Okay, so many students think that if you are increasing the temperature, vapor pressure is also increasing, so graph will be straight line. No guys, the graph for vapor pressure versus temperature will be like this. Okay, now why the graph is like this? So that we can see with the help of mathematical equations, but we will not go into that, right? Just keep in your mind that the vapor pressure versus temperature, we know that it is increasing. It is increasing, but they can give you this graph also, straight line, linear graph. So the linear vapor pressure and temperature does not increase linearly. Their increment is non-linear. That can be explained by the vapor pressure and temperature equation that I am not going to discuss with you because I don't think they will ask that equation, right? So that is the relation between vapor pressure and relationship between vapor pressure and temperature. The graph is non-linear increment. Okay, so let me write here non-linear increment. Non-linear increment. Okay, so this is the graph, very very important, already been asked in JEE May 2014. Okay, vapor pressure versus temperature. So if you increase temperature, vapor pressure also increase, and you can explain by this. Okay, now the third and the last factor is surface area. Third and the last factor is surface area. Third and the last factor is, guys, what? Third and the last factor is surface area. Now tell me how surface area will affect the vapor pressure. So if you will ask many students, they will say that sir, if you are increasing the surface area, then rate of evaporation is increasing, and if rate of evaporation is increasing, more vapors will form, and if more vapors will form, then they will exert more pressure, and if they will exert more pressure, vapor pressure will increase. Okay, this is what maximum students tell. But let me tell you the very important point, that vapor pressure is independent of surface area. If you are increasing surface area, still vapor pressure will not change. Clear? Now why is that? Because when students are giving me this explanation that when you increase the surface area, the rate of evaporation will increase, but they usually forget that vapor pressure, the concept of vapor pressure is defined at the condition of equilibrium. Okay, what is the condition of equilibrium? Rate of evaporation is equal to rate of condensation. So when you are increasing the surface area, yes, I agree with you that the rate of evaporation will increase. But guys, to attain the equilibrium, if forward reaction will increase, then backward reaction will also increase. So if rate of evaporation will increase at the same time or simultaneously, rate of condensation will increase. Okay, so what will happen? Both of them will increase simultaneously. So the amount of vapors that exert the pressure on liquid surface will remain same. will remain same, right? And if they will remain same, it means no matter whether you are increasing the surface area or not, the vapor pressure will remain same, right? So this is very important point, surface area, right? So here I am writing for you, okay, vapor pressure is independent. Vapor pressure is independent of surface area. Vapor pressure is independent of surface area. And why it is independent, guys? Because on increasing surface area, okay, rate of evaporation and rate of condensation increases at the same time. Okay, increase at the same time to maintain equilibrium. Okay, to maintain equilibrium. Therefore, okay, the amount of vapors exerting vapor pressure on liquid surface. Therefore, the amount of vapors exerting vapor pressure on liquid surface will remain same. Okay, so this is the explanation for that. Right? So please keep in your mind that vapor pressure is independent of surface area. Okay. Now I'm giving you one information that at 100 degrees Celsius, okay, if you measure the vapor pressure of water, okay, suppose you are boiling water at 100 degrees Celsius, close it, okay, then experimentally we can measure it with the help of manometer, right? So if you measure at 100 degrees Celsius, if you measure the vapor pressure of water, then it comes out to be 760 mm of Hg. 760 mm of Hg, right? Millimeter of Hg, 760 mm of Hg. So no matter whether you boil 10 liter of water, whether you boil 100 liter of water, whether you boil 1000 liter of water, its value will remain same, and that is 760 mm of Hg. It means vapor pressure is a type of quantity. It's a type of quantity which is not depending upon the amount. Okay, now let's say I'm boiling 10 liter of water. Okay, so boiling water has what temperature? 100 degrees Celsius. Now someone came and he or she took a little water, let's say 0.1 liter water. So what will be the temperature of 0.1 liter water? It will be still 100 degrees Celsius. It means temperature is the type of quantity whose value does not depend upon the amount. Of the substance. Okay, and these type of quantities we have learned already in class 11th. These type of quantities are called what? These type of quantities are called, guys, intensive quantities. Intensive quantities means independent of matter. So temperature is an intensive quantity. What about density? Density is also an intensive quantity, right? Density of mercury is 13.6 gram per cc. Or density of water is 1 gram per cc. Whether you take 1 liter of water, 100 liter of water, or 1000 liter of water. So density value will not change. So similarly with vapor pressure also. Okay, I gave you the one information that at 100 degrees Celsius the vapor pressure of water is 760 mm of Hg. No matter whether it is 1 liter water, 10 liter water, 1000 liter water. Okay, so I can say that here as an important point. Here I am writing vapor pressure is an intensive property. It means it is independent of. Okay, I think you can see that. Okay, it is independent of amount of liquid slash shape and size of the container slash shape and size of the container. Okay, so this is very important point regarding vapor pressure. Okay, this is very important point regarding vapor pressure. Okay guys, so this is it. We discussed the factors. First factor was intermolecular forces, where I told you that vapor pressure is inversely proportional to intermolecular forces, and the second factor was temperature. On increasing temperature, vapor pressure will increase, and we learned its graph also. The increment is non-linear, it's not linear. And after that, the third was surface area. So I told that vapor pressure is independent of surface area. When you increase surface area, both rate of evaporation and rate of condensation will increase simultaneously. So the amount of vapors that are in vapor phase exerting vapor pressure on liquid surface will remain constant, and that is why vapor pressure is independent of surface area, and vapor pressure is an intensive property. Vapor pressure does not depend upon the shape and size of the container in which you are taking the liquid. Okay, so that's it. That is the important discussion regarding the vapor pressure. Now vapor pressure is the basic of Raoult's law. If you will understand vapor pressure, then you can easily understand the Raoult's law also, right? Now one last topic, one last thing that I am going to discuss in this particular topic is the questions from one latest question from JEE in 2020 attempt, because this question is from JEE in 2014 that I discussed with you. Now the one last question that I want to discuss with you is from JEE in 2020 attempt. Okay, so I'm just writing the questions and then we will discuss that question. Okay guys. Okay everyone, now we have JEE in 2020 attempt papers. Question based on vapor pressure, right? So let's discuss that questions. Okay, so I have written the question on the board. Okay, so I hope that you can solve this question. So the question is, a graph of vapor pressure and temperature for three different liquid X, Y and Z is shown below. Okay, so this is the graph that is for three liquids, that is X, Y and Z. And these are the statements that are given to you, that X has higher intermolecular interaction compared to Y, X has lower intermolecular interaction compared to Y, and Z has lower intermolecular interactions compared to Y, right? And they are asking what is the correct statement, Okay, so let's focus now. Okay, so as you can see that whether it's liquid X or whether it's liquid Y or whether it's liquid Z, all of them have same vapor pressure. And the vapor pressure is 800 mm of Hg. Let's say the unit is mm of Hg. 800 mm of Hg. Clear? Now, pay attention here. Okay, so X liquid has this much vapor pressure at 293 Kelvin. 293 Kelvin, X has this much vapor pressure. And Y has this much vapor pressure, 313 Kelvin, and Z has this much vapor pressure at 333 Kelvin. 333 Kelvin. It means X can have same vapor pressure at less temperature. It means what? It is intermolecular forces are weakest because it is easily get convert itself into vapors. At low temperature, you can convert X into vapors and have the same vapor pressure. And what about 333? 333 means Z has strongest intermolecular forces. That is why to obtain the same vapor pressure as that of X and Y, we have to increase its temperature to 333 Kelvin, right? So for X it is weakest and for Z it is strongest. So we obtain that, right? Now pay attention. X has higher intermolecular interaction compared to Y. No, how can X has higher X so will have weakest. So A is to not right? X has lower intermolecular interaction as compared to Y. Yes, X has lower, so it can be the right answer. Z has lower intermolecular interaction compared to Y. No, that is not possible. Z has the strongest intermolecular interaction as compared to X and Y. So even C cannot be the answer. So our answer is only B. So is this B is given? Yes, option C is the right answer. In option C, the correct statement is only B. Okay, so you can see that the question was from very basics. So if you understand the vapor pressure, then you can answer this question. Otherwise, if you mug the concepts, then I am sorry, then I cannot help you. Okay guys, so that's all. This is the discussion of vapor pressure and what are the factors related to the vapor pressure, and we see some questions from CBSE as well as from competitive exams. So thank you very much. Now we will start with the next topic, and the next topic is Rod's law, an ideal solution and non-ideal solution. So thank you very much.